This question is about the neutral tin atom, which is located right as element 50 on the periodic table. The first question asks, what is the valence electron configuration? Remember that valence is going to be outermost S, so that would be right here, and any partially filled sublevels, so that would be those two as well. We don't include the D block because that is full with 10 electrons. So if we count our periods, we're at 1, 2, 3, 4, 5. We can see that our valence electron configuration is 5s2, 5p2. The next question asks, how many core and valence electrons does this atom have? Well, we can see that it is in column 4, and that it does have 4 valence electrons right here as 5s2, 5p2. The way to figure out the number of core electrons is to take the 50 total electrons, subtract the 4 valence, and we come up with 46 core electrons. The next question asks about how many p electrons are in the atom. So we need to go and look at the p block, which of course is right here for the tin. And we can see that we have 6 for the first row, 6 for the next row, another 6 for this third row, and 1, 2 for the last row. So that would be a total of 20 p electrons. The last question asks how many electron occupied, either with 1 or 2 electron, p orbitals are in this atom. So for this, we need to think about the fact that each orbital holds 2 electrons. So the 6 electrons actually belong to 2p6. The next set was the 3p. The next set was the 4p. And the last set was the 5p. So when we consider p orbitals, you know that there will be 3 of them, and that if we're holding on to 6 electrons, that would be a total of 3 orbitals. The same would be true of the 3p and the 4p. So I'll just draw those out quickly now, and slightly sloppily. Sorry about that, but I know you have limited time. So do I. So here are another 3 and 3 p orbitals. Now for the last set, which is the 5p with 2 electrons, we need to remember Hund's rule. Hund's rule says that we need to spread out the electrons among orbitals in sublevels and point them the same direction. So as you can see, we have only occupied 2 of the p orbitals in this particular set. So when you add them all together, we have used 11 p orbitals.